Welcome back everyone to this lecture on Matplotlib subplots. Now since we already know how to create a figure object as well as add a set of axes to it, in theory we could create a figure object and then manually add and arrange sets of axes to line up multiple plots side by side. So we could have one plot on the left and one plot on the right, or maybe a 2x2 matrix of plots. However, to save us time, Matplotlib actually comes with a pre-configured function call called 𝑃LT.subplots that automatically does this for us. The 𝑃LT.subplots call allows us to easily create a figure and an axes object in side-by-side formations. And what's nice about this is that the 𝑃LT.subplots command actually returns a tuple. So that tuple is going to create the figure canvas, and then the other axes object is essentially a NumPy array holding the axes objects. So what this actually looks like is when you call 𝑃LT.subplots, you provide the number of rows and number of columns you want for your actual set of axes. And then it's going to return both objects separately as a tuple. So you can then just assign it fig and then axes, where axes is going to be a NumPy array holding the individual axes objects. So for instance, if you wanted to expand this to maybe be 2 rows by 2 columns, it would return something like this. And later on we'll see how we can space these out to make them look a little nicer. The main idea here is that it returns both your figure canvas and then this axes object, which is a NumPy array that you can index to actually grab the axes to then plot on top of. So I keep mentioning this, but just to be clear, subplots is going to return that tuple. And by convention, we label it fig axes, where fig is the entire figure canvas and axes is that NumPy array. And the way it's organized is that it holds each of those individual Matplotlib axes objects according to position in the overall canvas. So let's actually explore how to use 𝑃LT.subplots to create and align multiple plots. I'm going to jump over to the Jupyter Notebook. All right, here I am at the Jupyter Notebook. I'm just going to quickly create 2 data sets with NumPy. So the first one is going to be, again, linspace that we've seen before. Let's go 0 to 10 to 11, and then say b is equal to a to the power of 4. So we get this exponential relationship. And then we'll also do x is equal to np arrange, 0 to 10, and then y is equal to 2 times x. And keep in mind, I could have used arrange for both of these or linspace for both of these, but it's just a reminder that you have 2 options here, depending on what you're trying to do. All right. So we have this exponential relationship and this linear relationship, so we can visualize them later on. So let's talk about 𝑃LT.subplots. And keep in mind, everything should be going in the same cell here. So I'm going to call fig, axes for tuple unpacking, and then say _PLT dot, and keep in mind, it's actually plural, TS, not singular. It's a little confusing because both the subplot command exists as well as the subplots command. And we're using the plural _PLT.subplots. And so the main parameters we provide here are the number of rows and number of columns we want. And by default, it just creates 1 row by 1 column, which means the axes is actually just a single set of axes. So when you run this, you essentially get an axes and figure kind of done all in one call. And then if we take a look at axes itself, notice that it's actually just a singular axes subplot. And so that means you could directly, if you wanted to, say axes plot xy. But typically, if we're just going to do one plot like this, we wouldn't actually call _PLT.subplots. Instead, we'd manually create the figure. So the whole point of _PLT.subplots is to add rows and columns to it. So what we can do here is let's go ahead and remove axes.plot and then say _PLT.subplots, and let's say we want 1 row by 2 columns. And so now you'll notice that it automatically returns the entire figure canvas as well as the aligned set of axes. So you no longer actually need to manually size and place these 2 plots together. So what's important to note is the minute you start asking for more than 1 row and more than 1 column, axes is no longer a Matplotlib axes object. Instead, if we take a look at the type of axes now, it's actually a NumPy array, which means it has a shape. And that shape essentially corresponds to what we're seeing here. It's going to have these 2 columns by 1 row. However, the way it's showing it here is just one-dimensional because there's essentially just 2 axes. So there's the first one on the left and the second one on the right. So if we come back to this same cell I could say axes, and then what I do is I index this, and then I can plot something like x and y. So again, in this case, axes is a NumPy array, so that means if I actually want to grab the Matplotlib axes object within it, then we call .plot. And I know it can be a little confusing with the variable choices here that I'm saying both the variable axes and technically the Matplotlib axes objects that are in it, these axes subplots right here. So feel free to rename this if it's confusing you, but by convention, most people just call it fig, axes. All right, so then I can say .plot xy. I run that, and I can see I've plotted xy on the left-hand side because that's the one that's associated with axis 0. Which means if I said axis 1 dot plot, I could say something like a comma b, and then it's going to plot AB here right next to it. And right now the spacing isn't so great, but we're going to learn how to edit that in just a second. But let's go ahead and expand this so now it's 2 rows by 2 columns. You'll notice immediately that I will get an error if I don't change this, and we'll explain why after we run this. So I run this, you notice it now creates that 2 by 2 set of axes on that plot, but it says, hey, I'm getting an error. This is a really common error for beginners to get when they're first dealing with plt.subplots, and it says this array object has no attribute plot. And the reason for that is now, since I have 2 rows by 2 columns, this NumPy array of axes is actually 2-dimensional. So let's check this out again. I can say type of axes, it's still a NumPy array. However, the shape now defines 2 dimensions, which means axes actually looks like this. It's axes subplot, and then a subplot and subplot again, which corresponds exactly with these 4. So for example, if I wanted to plot on the top left, I'd first have to say 0 in order to grab this first row, and then 0 again to grab the first column. And then I can plot on that. So I can come back up here and say, for example, 0, 0, plot xy, and then let's go ahead and comment out this second one. You can see here, I've now plotted on the top left. So if we wanted to plot on the bottom right, I'd have to think, okay, that's going to be index row 1, and then column index 1. So that's indexed at 1, 1. So then we can see here that I just need to say 1, 1 in order to plot AB here on the bottom right. So everything you learned about NumPy indexing with rows and columns is essentially going to be the same thing here, and it's all related to these subplot commands. Now, something to keep in mind that's really common to see is if you're dealing with something that's one-dimensional along rows or along columns, for example, let me go ahead and delete these, and I'm just going to say we're going to have 3 rows by 1 column. Very popular plot type to just see kind of 3 things stacked like this. Again, we'll show you in a second how to deal with this spacing issue. But if you get something like this, then again, axes shape is now just essentially one-dimensional. So you don't need to do this second dimension again. It's all just existing right here as essentially a list. The top one, the middle one, the third one. So because this is now essentially a single-dimensional array, you'll often see people do something like this. They can actually loop through it. So we'll say for x in axes dot plot something like xy. And here we can see now I've actually looped through this and plotted xy in all of them. And as you can imagine, x and y could be coming from another list. So it could be something like for x and axes plot maybe x of 0 or something like that. So you have this flexibility of actually looping through the axes if one of these happens to be equal to 1. But if you always want, you could just say axes and individually do something like this, plot x and y in order to only plot on the first one. Okay, so I keep mentioning we have this issue of everything seems to be very close together. You can easily fix that one of 2 ways. You can say plt.tightLayout at the very bottom of your call. So after you're done plotting on everything, at the very bottom of the same cell, called plt.tightLayout, or run this at the bottom of your script. And what it's going to do is it's going to automatically attempt to make sure that no set of axes, tickers, are overlapping over anything else. Now let's go ahead and walk through an example if you want to manually set the spacing yourself. So what we're going to do is come back up here, and let's actually change this now so it's 2 rows by 2 columns. And then what I'm going to do is remove tight layout here, And let's just go ahead and plot on some of these. So we'll say axis 0, 0, plot xy. I'm just going to copy this a couple times. And then change the parameters here. So then we'll say 1, and then 1, and then 1, 1. So I can see on all of these that I'm plotting xy on all of them on a 2 by 2 plot, so I get this spacing right here. And obviously, if you really wanted to, you could change one of these to like A and B, so you can see the difference here. But the main thing I want to point out is right now that with the default, it looks like it's a little too close together on some of these. In fact, you can see here that the ticker is overlapping on the other set of axes. So again, we could say PLT tight layout and try to fix this. And to some degree, it does fix this, but maybe this is still too close to you. So what you can do here is call the PLT subplots adjust parameter. So the way this works is at the very bottom, what you're going to have to do is say, in fact, you call it off of figure, not PLT. So you grab your figure object and you say figure subplots underscore adjust. And then there's a bunch of parameters to call. So you notice right here, you have a left, bottom, right, top parameter, which you can adjust. But the main ones for spacing are really just the width space and the height space. And you can check out our lecture notebook for examples of what all of these parameters mean. But essentially, this refers to the left side of the subplots figure. This is the right side of the subplots figure. This is the bottom and the top. And then if you want to deal with spacing, these are the ones you want to edit, which is W space and H space, which is first W space, the amount of width reserved for space between subplots. And the way it's expressed is as a fraction of the average axis width. And then H space is the amount of height reserved for space between subplots. Again, expressed as a fraction of the average axis height. Now this can get a little complicated with so many parameters to adjust, so I do want to point out that in the actual lecture notebook where we talk about manual spacing on subplots, we have a link here to the documentation that you can open, and it goes into a lot more detail about each of these commands as well as many examples of adjusting the spacing of all these. So I encourage you, if you find yourself having to do this, go ahead and just check out that documentation link. But for right now, let's just answer the question of how can I manually edit that width and height space based off of a fraction call. And again, this is probably something you want to experiment with, but what I like to do is we'll just keep left, bottom, right, top as none. And let's just say W space is equal to 0.9 and see what that changes. So you notice all of a sudden there's a lot more space here horizontally along the width. And again, it's expressed as a fraction of the average axis height, or excuse me, in this part for width. So 0.9, so 90% of the average width of these axes. So you can see it looks like it's spaced out more or less by an entire axis width, which makes sense because if I say 1 here, there's essentially a set of axes that could fit in between the width. And if I said H space is 1 as well, then we essentially have a set of axes in between both width and height here. If I wanted to make one of these closer together, I simply start adjusting these ratios. And again, it's based off the average axis width and average axis height. So again, just subplots adjust and start editing W space and H space. Those are probably the ones you're going to find yourself editing the most. And finally, to finish off this lecture discussion, what I want to talk about and show you here is exporting the subplots as well as editing the parameters of the subplots. So we're going to come back and basically discuss what would you change. Let me add tight layout here real quick. What would you change if you wanted to maybe add a title or an X label to one of these plots? Is essentially you just grab that particular set of axes. For example, we'll grab 1, 0, and then you say set, and it's all the same commands as before. You can set the X label, you can set the Y label, so we can say Y label 1, 0, run that, and suddenly there's a Y label here. And if you wanted maybe one of these to have a title, you could say here axes 1, 1, go ahead and say set underscore title. Same commands as before. You can say title 1, 1. So you run that and you see the difference there. And obviously as you add more stuff, you can always end up creating spacing between them, and you can always set the limits as well. So for example, let's say we wanted to just set the limit on this bottom one from 2 to 6. I could always just say, okay, come over here grab that set of axes, and then say dot set either xlim or ylim, and then I could set it to whatever values I wanted. So you have full control over each of these set of axes in the same way we learned about when we're talking about figure object. The main difference here is you're going to have to either loop through these, or more likely for something that's 2 by 2, is you're going to have to manually grab each one and then set x limits and set y labels and titles, etc. So the last thing I want to show you is if you actually want something like a title on this entire plot, what you can do is for a figure level title, instead of calling it off the axes, you can say something like fig subtitle for a super title. This is like a figure level title. So here's figure level, and if you want, you can then start adjusting things like the font size on it. So you can actually expand on this, and it will eventually tell you things like the x and y of the location, horizontal, whether you want it center, left or right, the font size, vertical alignment, etc. So there are a ton of parameters you can do on this. And honestly, Google search and Stack Overflow are your friend. You can just quickly search, how do I set a figure level title on subplots? And you would quickly find out that it's just subtitle. Okay, so we have this figure level title. Finally, let's talk about saving this plot. So let's imagine I'm satisfied with this, and now it's time to save it. The way this works is, as before, we simply call at the very bottom of everything fig.saveFig, and then call this whatever you want, such as new subplots.png, and recall that we should be saying bounding box inches tight in order to make sure that we actually have a bounding box that isn't going to cut off anything. So we say bounding box inches tight, save this as new subplots.png, and if I run that, I am able to save this title, or save this image. Let's go ahead and open it up, scroll down, just a few seconds ago, new subplots.png, and there it is. And as before, you can edit stuff on the figure level, just as you did with the Matplotlib figure object. So you can edit the figure size, the DPI, etc. So I can come back here and make all those changes as well. Now there are many ways to do this. One is to do it off the figure object itself. So there are commands that allow me to do something like this, fig, and then say set underscore, and I can say set underscore, for instance, set figure width, and I can set this to much wider. Maybe I could set it to 10, and you'll notice now it's a lot wider. So there are figure level options, but probably the easiest thing to do is a lot of those figure commands that we learned about earlier for the figure object, it's actually available within the subplots call. So if I expand on this, I get to later on see this figure keywords. So all the keywords that we learned about on the figure object are actually available to us inside of subplots. So I could just say up here, fig size is equal to something like, let's say 4 by 10, and then I could say DPI is equal to 200. So I can run that as well, and it starts editing it just as we learned about before. So those figure level objects, you'll notice that subplots has no problem taking those as well. All those figure keywords, they can come in and be accepted into subplots. So this makes the doc strings a little harder to read. Otherwise, it'd have like 1,000 parameters here showing you, but it does show you plenty of examples in the gallery as well as in the documentation. So as you scroll down here, you'll see a bunch of examples and explanations. Okay, so I know that was a lot, but basically the main idea behind all of this is when you call plt.subplots, you get to ask for the number of rows and number of columns, as well as specify any figure, and then you'll go ahead and get a figure object and then this NumPy array of axes. And each of those axes objects is held within that NumPy array, and you can plot and set parameters. There's lots of examples in the lecture notebook, but keep in mind that's really all there is to it. This subplots command automatically creates the figure and a NumPy array holding these axes, which you can then index and then plot out. Okay, thanks, and I'll see you at the next lecture.